How's it going? I'm Eric Little and I'm part of the Pitchfork Music Reviews group, and this is our video of our demo. So we're going to start off with a bit of our presentation. So like I said, we did a project surrounding Pitchforks and their music reviews, and so I'll jump right in. So the overview of the application is that we really wanted to aggregate and compile and visualize the reviews made by Pitchforks. So Pitchforks is a massive music magazine, one of the first ones. They're really a voice of the music industry, especially when it comes to reviewing albums. So nearly every big name album, they review it and give it a and give it a score on a scale of 1 to 10. So very quantitative, and they write descriptions about them. And a lot of people really look at these. So the goal of our application was to be able to take all of these reviews, like we said, this quantitative data, and be able to visualize it and aggregate it for people so that they're able to see things that aren't just one review at a time, or maybe the reviews that are for that week, but really over the course of a year, over the course of an artist, things like that. So our general users, so this can really be anyone that's interested in music. It can be your casual listener who may just love listening to Drake and they just want to see what Drake's albums have been reviewed by Pitchforks, or it could be someone who is really passionate about making sure that the people that might be signed to their label or the people that they're invested in, they're successful and they're doing well. And so you'd be able to see all of these with our website. So this is because right now on Pitchforks it is not easy to actually view things, whether it's in graphs, whether it's in tables. Instead, it really is just their review pages, and so we wanted to be able to have music fans be able to see things in a more cohesive manner. And so hopefully we're allowing all users to be able to use our website. And so here's the functionalities, and I'm actually going to exit out of this presentation and go into our website to describe the functionalities to you. So this is the homepage of our website. As you can see, Pitchfork Music Reviews, and this is our main search bar. This is really the main tool that we wanted to focus on, and I will get to that. But just going through the main page, these are some of the top albums to have ever existed. So you have Michael Jackson, Off the Wall, and a little description about that. You have, People's Instinct Travels in the Path of Rhythm by A Tribe Called Quest, A Love Supreme by John Coltrane. These are some of the top albums that received scores of tens over the years, which Pitchforks does not give often. They're very stringent. They're a very respectable music source, so they don't want to be just giving out tens all the time. And finally, here's the about, which we'll talk about later, but we got these Pitchfork reviews from Kaggle. Someone actually went through and scraped it. So fortunately, we did not have to. We didn't have to build that Python script or something like that. We were able to just get the data from Kaggle, and the link to the data set is right here. So diving into a typical user flow here, say it's someone that is not really sure what album they want to search for, so they can just go to the Albums tab. Here we have all the albums. You're able to just scroll through. You're able to hit Control F. But again, this is for people who don't know what albums. So we wanted to give albums at the top that maybe you haven't heard of. So for example, if we pick First Songs, it loads here, and you can see this dial that we made using D3 connects to the back end. And actually, what happens is that it passes through the score that was given from the review table. It passes that through to the front end using D3. And here in the D3 code that we wrote, which was in JavaScript, we were able to place this score from the reviews table of our database into it, and you were able to create this dial, which out of 10, if it was completely filled up, or if it was really low, near 0. And then here we have the review URL. Again, as you can see in the bottom left-hand corner, it will pop up, and it'll actually redirect you to the album on Pitchforks. And the way we're able to do that is a very similar way. We're able to take the URL from the review database table, which I think is something that is very interesting for people to see, so they can see the context behind the URL. And then also we have the date that was reviewed in case there are multiple First Songs. You can say, okay, this one from 2017, not, say the one from 1950. So this is what we wanted to show you and how it's actually passed through. And I'll talk more about that in a second. But I just want to keep going along through some of the use cases. And so I just want to show you that we're able to take care of ones with spaces and also take care of ones without spaces. So as you can see, Mezzanine here, really high score, 9.3. We think that's something that is interesting. And yeah, so then sticking with albums is what I want to do here for this current time. So if we go back to the home page, which this will redirect you to the home page every time, we can actually go and search for an album. So if we look up So Far Gone, for example, you can see here that here's So Far Gone album. And we say, great, only 7.4. I'm a huge Drake fan, so I think a 7.4 is honestly a little bit low, but that's just my personal opinion. But you can see that the search functionality actually works. And so it's not case sensitive. As you can see there, I put in all lowercase, which I think is something that's great. We use to lower, the Python function. And so just walking through now kind of the back end more than just the user flow, the All Albums tab takes users to a page which contains all the albums listed in the database, as we said here. And from here, each page is hyperlinked to another page which contains the information about the album, including the Pitchforks review as you saw, as well as release date and its score from the review. It's supplied by SQL queries and app.py, which dynamically fetch that information from the database upon clicking the album name. And the page also features the dials, which are dynamically generated by D3, which I talked about a little bit before while you're on the page. And so then going back to the search bar functionality, that actually enables the user to search for an album and any artist they want. For simplicity's sake, we decided to make the design decision to only have the search bar be present on the first page of the website, as we felt it would be a little bit redundant to have a search bar on each page, so we wanted to keep it there with a very easy routing back to that home page using Pitchfork music reviews, doing an index.html page essentially to get that to be the home page. And we use Bootstrap to create all the visualizations here. So for albums, the user simply clicks the drop-down box, as we did here, selects the album, and then types their query. For the specific example, I use So Far Gone. And so the backend looks through the reviews database for any album that contains a specified search string, and then adds that to a Python list. So for example, added So Far Gone. Then on the HTML side, the Jinja in the file results.html runs through a simple for loop and takes the information from the list, then displays it in the format album.name, album.reviewID. The links are then hyperlinked to their respective pages within the All Albums tab. So you see there's a lot of stuff going on in the back end here, connecting lots of tabs, using different databases, or using different data structures. And so on the other hand, if we want to search for an artist, it's a super similar process, which I will get to in our next spot here. So this time we'll start off, say they have a very specific artist. Like I said, I really like Drake. And so there's all these people, Drake. And so what we'll do is we'll click on this one here, and then we can see that, oh, great. Okay, here are all of his album ratings. So these are all the albums up to 2017, which, as I will talk about in a second, as we go back to the slide deck, that's all we have the information up through, which has been parsed. But as you see there, all you do is simply click artist on the drop-down, type in the artist name. The processes are very similar to each other, with the sole exception being in the artist case. The SQL query involves searching through the artist table rather than reviews, and displays the artist name as well as the review ID corresponding to the review. Clicking on the artist name takes one to their respective page within the website, and that is what we wanted to show here. So as you can see, each bar actually has the score of that album. So that's something that we really like to see, so you can see which ones are the best. So I think my personal favorite album is If You're Reading This Too Late, but it actually does have a lower score than Nothing Was the Same. And so that was how that search functionality works. Or you can just go to the artist tab, very similar. You have them all listed on the side here. And so the artist tab was built using the URL for method in order to create hyperlinks to each artist name. In this way, create unique URLs for each artist. Once we click on the artist, the backend queries through the database to find the scores for each album with that artist. This is done through the app.py file again, which contains all the code that sets up the Flask web app and connects the backend queries to the front-end HTML files. And by querying through the specific reviews that match up with the artist that was clicked and find the individual scores of those albums, we're able to start filling up our album scores array. So again, lots of data structures coming in play here. This array along with the artist name is passed through to the front end side of it using the render template, and this allows us to have the information in the front end. The front end imports to the Google Charts API, so we wanted to introduce D3 and Google Charts in order to have, in order to show that we're able to manipulate our data in multiple ways, and that we really understand how the tables worked, which we use to create the pretty bar chart that is loaded in the HTML file. Which is more front-end work that we did. And this allows us to see the chart that displays every album and its respective scores. So for example, Tasso here, all they have is New Start. So that's one thing to consider. Or you can look at, for example, who's the person that would have a lot? If we go back to Run the Jewels, they likely have a lot of albums. I know they have extensive work. Yeah, so lots of Run the Jewels albums around the same kind of rating. And since we had the album scores array, we're able to feed that array to create the bar chart with that information, which finalizes our look for the individual page that renders a summary of every artist's albums. If we would have had more time, I think we would have liked to implement the bubble chart D3 visualization as the main page of the artist tab. And that really would have looked like when you clicked on artists, you'd have all these bubbles flowing around the artist name in it and their reviews, and the size of the bubble would be based on the review, the average review. So I think that that's one thing to consider. And so, however, since our database is more than 18,000 tuples, building the bar chart would require more time to optimize the queries and make it efficient. So we decided to not add that at this time, which I think wasn't necessarily something that we missed out on, but I think it was something that really could have looked cool. But in this part, we definitely do protect against SQL injection attacks. We use the same format that we learned in the lecture, and we also met with the collab in order to do that on the back end, or to protect against these attacks, so that when we're using Python, we're not just doing simple variable assignments or things like that. Otherwise, some of these attacks really might be possible. And in order to optimize the database, which I'll talk about in a sec, we did use lots of triggers. So for example, you're not able to have reviews more than 10. Your year can't be over, 2020, things of that nature. Your month has to be within 1 through 12. So I think that that was one thing that we did um, in order to safeguard against some of these things. And actually, we even built in here. So if I type in some random gibberish, it should say that there are no results that match the query. So that was another trigger that we actually added, was that if it didn't match something in the database, it wouldn't go through it. So that is really a walkthrough and a demo of our website. On the top albums brings you back to here, and about brings you back down, but that walks through the artist page. It walks through the search bar that we have, and it walks through albums. And then finally we have years. And so what that does is we have all the years from 1999 to 2017. And the reason we have that is because then you're able to view the top albums of each year. So we really wanted to show that, because at times you might think, okay, what was the best album? Let's say 2016. And apparently it's Tonight's the Night or 1999 In Concert, Hounds of Love. 2017, it's Mezzanine, First Songs, Run the Jewels 3. 2015, you had things like Astral Weeks. And you're able to do this in a very similar manner to what we did for the previous tabs in terms of interacting with the back end and things of that nature. So year displays all the years, and then when we select the year, it passes the year chosen as a parameter to a query that returns all the albums from that year. Then it is sorted by score using a SQL query, and then the first 10 are, using choose 10, are passed to the front end, which is the year/chosen year page, as you can see in the URL bar. So it works pretty similar to the selected artist tab. So that was a demo of our website, and then going back to our slide deck. These are the functionalities we talked about that you can review if you don't want to watch the full demo. But then we also have, here are the data tables that we use. So our data set had 18,389 tuples. So we tried to get into the double-digit thousands. We couldn't get to 100,000s, unfortunately. We couldn't go that far back from the data that we had. But we were still able to almost get to around 20,000. And you can see that each table had different attributes. Review ID was the primary key from review, and was a foreign key in album, artist, and author. That made it so that we were able to actually link together the artists and their review scores rather than having to put it in each table. And so this was one way. One thing we learned through earlier on in this database course that I found was very, very helpful for us. And so we were able to manipulate these tables. We felt that this was the best layout of it in order to make the tabs that we wanted. And as we'll talk about in further steps, I think we would have made a possibility to add yourself as an author if you had wanted, but I'll talk about that. That's why we actually built the author table. And so like I said, we did use triggers to make sure that as people were putting in these reviews, or as reviews were going in, we made sure that you couldn't put in a month that was outside of 1 through 12, a year that was outside the specified range. No review could be without a score. No album could be without a title. We felt that these would make things really difficult. So we wanted to make sure that we did this, and we felt that this really optimized our database and allowed us to have conformity and uniformity across all of our different tables. And I think, as you saw in the demo, that allowed us to actually move through things pretty quickly. It didn't take that much time to search up. So we think that our queries were actually relatively efficient. We didn't use any really prepared statements just because we were using a Flask database where we didn't have to use any tables where we need to do that, but we did implement these APIs, the D3 library and the API to kind of make up for this and just to show that we were able to understand and manipulate our data. And so finally, challenges in future work. One thing we would have really liked to add is the ability for users to put in their own ratings and then compare these with Pitchforks reviews. We think that this would have been great for two reasons. One, we would have wanted to see how close we were in our opinions to what Pitchforks reviewed. And then the second thing is that maybe based off of some of these reviews, we'd actually be able to recommend albums for them. But I think it would have been an entirely separate project that we would have had to build out. But that's something for the future if we were to continue this, with an independent study or something like that we would want to build out. And we would have, and then as I said before, we would have wanted to implement that D3 visualization to have the bubble chart present. So that's one thing that we weren't able to do at this time just because there are so many tuples with so many different artists. So we wanted to make sure that that we were able to do that. And then the large challenge we faced was definitely implementing this visualization. As we said, there were some we couldn't make. And then even with some, it was relatively difficult. It was hard enough to build a web application, but using other libraries and APIs, it made things extremely difficult at times. But the best part of this project was knowing that we were able to build things from scratch and that we were able to problem solve through problems and look online and get information about how to solve these. And I think it really helped us come together as we tried to tackle each other's problems. We had to make sure we're writing neat code, and I think overall really enjoyed it. So we hope that you enjoyed this presentation, and we hope that you enjoyed our web application. And reach out to us if you have any questions. Thank you.